Right. Hello and good morning and good afternoon, everybody. I'm Spencer Allingham. I'm the Technical Director at Conducive Technologies. And I've been invited along by Stephen Nell from iTree Solutions in South Africa to talk to you about the two silent killers of virtual machine performance and what we can do to combat that. So without further ado, let's get straight into it. So first, a little bit about us and who we are and where we've come from. We're a 34-year-old software company, and we rebranded to Conducive Technologies about 4 years ago because we expanded our technology to focus on optimizing I/O streams in virtual environments to help organizations get 50 to 300% faster application performance on their existing hardware. Now, because of our work to solve the I/O problems in virtual environments, Gartner named us Call Vendor of the Year and recommended our deployment with every virtualization initiative. Also, Storage Magazine named us as Storage Software Product of the Year. And in addition to this, our technologies are OEM'd by 9 out of the top 10 PC manufacturers in the world, and others like Western Digital and SanDisk. We've got deep relationships with Microsoft as a gold partner and VMware as a TAP partner. And over the years, we've sold over 50 million licenses worldwide and have enjoyed a 90% footprint in the Fortune 1000. Now, virtualization has been great for server efficiency. But here's the dirty secret about virtualization. It adds complexity to the data path. And due to this added complexity, virtual environments suffer from I/O characteristics that are much smaller, more fractured, and more random than they need to be. Large sequential reads and writes break down into small, fractured, randomized I/O streams. What this means is your systems are processing workloads about 50% slower than they should, because your system performance is suffering tremendously from all this tiny random I/O that's chewing up all your throughput and making you more IOPS dependent than you actually need to be. Now, even though virtualization is known to add complexity to the data path, native virtualization out of the box does absolutely nothing to solve or compensate for this problem. And this is the dirty secret that your storage vendor doesn't want you to know about, because your only choice is to overbuy and over-provision for performance from a storage hardware standpoint. Our V-locity I/O reduction software solves this problem. And as a result, our typical customer experiences anywhere from 50 to 300% faster application performance on the hardware infrastructure they already own, depending on how bad their workloads are being taxed by this problem of small, fractured, random I/O. To get an idea of what V-locity does, let me show you. ESG Labs, an independent analyst group, examined the results from the 3,500 VMs that tested our software in production environments at over 100 different sites and published these results to show what our software does across a very large scale. The first thing you should know is that over half of all systems that used V-locity saw a 50% or more reduction in read I/O from VM to storage. But it's not just read I/O. V-locity also reduces write I/O. 27% of the systems saw a 33% or more reduction in write I/O. In fact, 14% of the systems suffer from such high levels of I/O inefficiency that they realized a 50% or more decrease in the write I/O. So when you add up all the read and write I/O that we're able to eliminate at the VM OS layer, and offload all of that from the underlying storage system, you'll see that you get big improvements in throughput, response time, and IOPS. In fact, the next slide shows you exactly how much. You can see here that nearly half of all systems that test velocity see a 50% or more jump in throughput, in productivity. In fact, a third of systems are taxed so badly by the problem of small, random, fractured I/O that they get a 100% increase in throughput or more with our software. And as far as response time goes, we deliver on average a 40% decrease in I/O response times across all I/O on all systems. And here's an interesting one. 25% of systems actually get a 50% or more jump in IOPS. Now, you would think IOPS would actually go down with our solution because we're eliminating those tiny I/Os that are chewing up your performance and stealing your throughput. But since we're improving the sequential nature of I/O streams and serving some of that I/O from available DRAM, IOPS actually goes up, as these systems are now able to do more work in the same amount of time. Velocity is a 100% software approach to solving your toughest application performance challenges on the hardware infrastructure you already have. And it does two things to deliver the kind of benefits I just showed you. Our first patented engine improves the sequential nature of writes and subsequent reads by helping Windows write files in a contiguous, sequential, unbroken manner. That means instead of needing 80,000 I/Os to process a gigabyte of data, you may only need half of that, or perhaps even less. And that's why we're able to drive up your throughput so significantly, because it takes less I/O to move any unit of data, and we make sure it's processed in a sequential manner. The second thing we do is reduce latency by caching reads from the idle available DRAM that you already have. In effect, establishing a tier 0 for your caching strategy right at the top of the storage stack. And what's nice is that you don't have to allocate anything for cache. It just dynamically uses some of what's available, so there's never an issue of resource contention or memory starvation. Now, you may not think of available DRAM as having enough capacity to have that much impact, but it has a huge impact. And that's thanks to our intelligent analytics engine that's application aware, and also due to the fact that DRAM is roughly 10 to 15 times faster even than SSDs. So as you saw, over half the systems that test velocity see 50% less read I/O going down to the storage. And with just 3 gig of available DRAM per VM, the average reduction in response times is 40% across all systems. So by having one engine that's sequentializing writes for more throughput and another engine that's caching reads on your available DRAM to reduce latency, that's how our typical customer sees anywhere from 50 to 300% faster performance on their existing systems. But what does our typical customer profile look like? Well, first, they've virtualized. Second, they've run into an I/O ceiling of sorts on one or two of their most intensive workloads, and they're finding them tough to support. It might be a back office batch job or a report taking too long, perhaps slow database queries or latency spikes under a peak load. They might be getting complaints from staff about one or two I/O intensive applications, and typically they're thinking about adding more flash to tackle the problem, maybe adding another expensive hybrid or all-flash array, or even possibly, in some cases, ripping and replacing their SAN before its life cycle is complete. And that's usually when they find us, and we come in to help them evaluate velocity and demonstrate how we can solve their toughest performance challenges before they spend a lot of money on expensive new hardware that isn't actually going to solve the root cause of the problem. So ask yourselves, what would you say are your most I/O intensive applications? The ones that are toughest for you to support from a performance standpoint. Are you having any performance issues on those workloads? Are performance issues causing any aggravation for your staff or your customers? Do you have any idea how that affects the business? Or do you have any back office jobs that are taking too long to complete? And the type of applications I'm thinking about typically tend to be things like SQL, Exchange, maybe file servers, file and print, business information apps like IBM Cognos, that sort of thing. Anything that's very storage hungry in terms of I/O traffic. So here are those two silent killers of VM performance. Firstly, your performance is being taxed by split IOs. Keep in mind that each IO that is generated takes a measurable amount of time and resource to process. So it's much more efficient, for example, to save a 20 gig file in 1,000 IOs than it is to save that same 20 gig file in 20,000 or maybe even 30,000 IOs. When you split writes up in this way, it makes everything work much harder than it needs to, all the way from server to storage and back again if the data gets read back at a later time. Think of it like this. If you've got a liter of water, which is the data on one side of the room, and you need to move it to the other side of the room, which is the storage, it's much more efficient to make one trip with a liter-sized jug than it is to pour that liter of water into tiny paper cups and then take the first cup across the room and then come back and take the next cup across the room and then come back and take the next cup across the room. You can see how paper cup-sized IOs make everything work so much harder than it actually needs to. So that's your first performance penalty or performance tax. The second is the I/O blender effect that happens in virtualized environments. And this is where all those small fractured I/O packets get mixed together like a blender in the hypervisor. And this randomizes the storage I/O traffic. And what comes out from the hypervisor is a chaotic mess of small, fractured, and now very randomized I/O streams that by the time they reach the storage controller at the bottom, couldn't be less storage friendly to process. It means that the storage controller is only receiving data in very small chunks at a time and only has the opportunity to create very small stripes across its media, causing many more storage level operations to be required. V-locity stops split IOs from occurring in the first place. And it does this by adding an extra layer of intelligence to the Windows write driver so that instead of splitting writes up, it finds a large enough area of free space on the logical NTFS volume to write that data into without having to split it up. The result is you get much fewer IOs going down to the storage and each one carrying a lot more data. So now the storage is receiving data in larger chunks at a time and has the opportunity to create larger, more sequential, unbroken stripes across its media using fewer storage level operations or transactions. V-locity also uses a RAM caching technique using otherwise unused memory. And by satisfying a good percentage of the read I/O traffic from a RAM cache at the Windows layer, it means two things. Firstly, that traffic gets satisfied much faster than the storage could deal with. As I mentioned before, server-side DRAM is roughly 10 to 15 times faster even than SSDs and flash. Secondly, this is traffic that's offloaded away from the storage, helping to further reduce I/O queues and freeing up very valuable I/O bandwidth for the rest of the traffic that does still have to flow out to the storage. So here's that I/O blender effect again, before and after V-locity. On the left, you have that chaotic mess of highly randomized and fractured I/O that's very storage unfriendly. On the right, you have V-locity sitting in the Windows operating systems, satisfying a good percentage of the read I/O traffic from there. It's also making sure that the split I/O situations are prevented so that you have fewer packets traveling out to the storage, each one now carrying a good amount of data. Because we sit at the Windows layer as just a piece of software, this gives several key benefits. Firstly, we can use a telemetry technique to learn over time what type of applications are being used in the machine, what type of files they're accessing, what type of I/O streams are being generated, and at what time of the day, the month, the week, the quarter, so that we can become very intelligent about what needs to be in the RAM cache and when. It also means that we can be completely agnostic about the type of hypervisor you're using and the storage. It's still Windows generating a standard NTFS I/O that flows down the storage stack. So as long as your hypervisor and storage is compatible with the Windows VM sitting above it, it will be compatible with V-locity. It's worth noting that we've got 15 published case studies. In fact, I think we've got a few more than that now, in which customers all experienced a minimum of doubling in performance. Christus Health up here on the top left, they virtualized their electronic medical record application, and they ran into some major performance issues. And they were about to sign off on a $2 million NetApp purchase, but they evaluated V-locity first and found out that we were able to double their performance, and they ended up canceling the storage purchase. I understand the chap from NetApp was very, very cross, as you can imagine. Bell Mobility down here, they had a custom application sitting on top of SQL that was taking way too long when users tried to generate reports. They tried V-locity, and we reduced I/O to the SAN by 61% and tripled the performance of their SQL queries. Stockport College over here, it was 15 minutes to process one student record, but after V-locity, that average dropped to just 5 minutes. They put V-locity on their finance machines, and payroll jobs that were taking an hour and a half dropped to just 15 minutes. The last one I'll pick out of here is ASL Marketing here in the middle. They had a huge import job into their SQL database that was taking 27 hours. V-locity cut that to just 12 hours with just a simple piece of software. So V-locity can be evaluated, and this way you can see exactly what kind of performance gains you will get in your real-world environment before making any kind of purchase commitment. Some customers use their own performance monitoring tool to validate the before and after benefits, but the product does come with its own embedded tool called the Benefit Analyzer. And this monitors and reports on your workloads before running V-locity, then collects data after V-locity has been running, and puts together a really clean before and after comparison on all the key performance metrics you would care about, and puts it all into a report form that you can share with supervisors and stakeholders to validate. Now, this, though, is where most people choose to start, and it's a sensible place to start. We have a separate product which everybody just for turning up today can get a copy of this. It's the free, no obligation I/O assessment tool. And the reason this is such a great place to start is that it will measure to look for performance issues, but it will do so in a completely non-disruptive way. There's no software to install, there's no agents to deploy, there's no reboots required. In fact, it's just a simple executable that you run on a machine. You give it a list of the machines to measure or monitor, give it some user credentials so that it can access those machines, and you tell it how long to monitor for. And what it will do is use Windows Management Instrumentation, or WMI, which is a part of the Windows operating system, to gather the measurements that are already inside each Windows installation. Typically, those measurements get used by things like Windows Performance Monitor, or PerfMon, or Windows Resource Monitor. And it gathers these, and it puts it into a little CSV file, and then analyzes that at the end to produce a report similar to one you can see here. Now, one of the great things about this report is that it will color code your servers into red, yellow, or green, so that you can very quickly see which systems are being critically impacted by performance issues, which servers are being moderately impacted, and which servers actually are running just fine. There are 11 different metrics that are measured, so things like the amount of workload in gigabytes, the I/O response times, I/O queue depths, number of split I/Os being generated, and so on. And then at the end of the report, it will tell you what the potential is for performance optimization with a product like V-locity or Diskkeeper. And then underneath that, it will explain why it came to that conclusion. So in this case, we were seeing critical levels of unnecessary split I/Os. We were seeing critical barriers to achievable data throughput rates and critical lags due to conflicting I/Os from remote systems. So that's the I/O blender effect. As I say, this is a great place to start. And I would certainly welcome you to reach out to myself or to Stephen at iTree and request a copy of this. Even if you are viewing this after the session has closed, still feel free to reach out to Stephen. And I'm just going to get his contact details up so that I can read them out to you. So his name is Stephen Nell. The company is iTree Solutions. His email address is stephen.n@itreesolutions.co.za, and you can call him on 011-609-0525. Please do pester him for a copy of this tool or get in touch with me directly. You can email me at sallingham@conducive.co.uk. And yeah, I hope this session has proved informative and useful, and please do feel free to reach out with any questions. Many thanks for attending. Take care.